Hello, today we would like to introduce the principles of watership. Before we talk about the watership, we should know why ships float on the ocean. When the ship is on the ocean, the ship experiences a force called the buoyant force from the water. This force acts on the center of buoyancy, which is the centroid of the displaced volume of the water. The buoyant force is equal to the weight of the displaced water by the bottom side of the boat. First, the buoyant force can help the ship to overcome the weight of the ship. To increase the buoyant force and the maximum load of the ship, most of the ship will use a long and wide hull.
This is a rotor ship. As you can see, the major difference between rotor ships and other ships is that rotor ships have spinning columns vertically mounted on the ship. Some may think that the columns only make the appearance of motor ships stand out, though they are actually extremely practical. The spinning columns serve the same purpose as sails. They make use of the wind current on the sea and allow the ship to move with less power. In other words, the ship is more energy efficient. But how do the spinning columns work actually?
Rotor ships can use natural wind power for sailing just like sailboats. As the rotor on the ship rotates, on one side of the rotor drives the air to move faster. On another side, the rotor slows down the air due to friction between air molecules and the rotor. According to Bernoulli's principle, air that moves faster has lower pressure than air that moves slower. So the air exerts a force on the rotor, helping the ship turn. As there is side wind on the ship, it can be used to propel the ship forward, increasing fuel efficiency.
Langus effect. When an object is rotating and moving toward one direction of the object will move along the airflow and another side will be opposite. Particles in the side moving along the airflow will become less dense because particles in this side move in one direction only, and particles in the opposite side will meet each other and become more dense. Therefore, a low pressure zone will occur in the side of the object which moves along the airflow. A high pressure zone will occur in the side of the object which moves to the opposite direction of the airflow. Air will move from high pressure to low pressure and create force in this process. In a watership, water cell will create a force if wind is blown from left or right side by rotating clockwise or anti-clockwise. It can help watership save energy and move.